Problem number 7, vertical downward motion. How many seconds are required for a stone to fall 27 meters? So we are going to solve these problems in 3 parts. One is sketching a diagram. So here we have a stone that is falling, and how much will be the time when this stone has fallen 27 meters. So now we are going to draw a data table that incorporates all the variables for motion, which is initial velocity, final velocity, distance, acceleration, and time. Now you are going to fill this table based on this story, on this sketch. So your initial velocity, because it's falling here, didn't mention anything, you are going to assume is 0. Then final velocity didn't say nothing, so leave open. Distance is 27 meters, which is the height. Acceleration is 9.8 meters per second square, acceleration of gravity. And time, this is what is the problem is looking for. So final velocity, we just mark a dash because it's not relevant to solve this problem. Now we are going to look the selection of equations that can help us to find this answer. So you look at the table and you look at the possible equations. So 1, 2, and 3 equations when acceleration is different than 0, and the last one is when acceleration is 0 and velocity is constant. Okay, so this is not the case because we have acceleration. So for equation we are not using. Now, the equation number 3, we need to find time. So we don't have time in this equation. So another one that we can eliminate. Now we have equations 1 and 2, but equation 1 does not have a distance. So by elimination, we are using equation 2. So D is equal VIT plus half AT squared. So this is the equation. So our D is 27 and our VI is 0 times time plus half. A is 9.8 and time is what we are looking. So this is 0. Now we have 27. 9.8 divided by 2 is 4.9. T squared. Now we are going to divide both sides by 4.9, and 27 divided by 4.9 is 5.5 is equal to T squared. So now we are going to square root both sides. So T is square root and 2.35 rounding seconds. So that's the time that takes for this stone falls 27 meters.